All right, chemistry students, we are looking at an experiment today, and today's experiment is going to be about chemical properties. And the handout that you have, we are going to fill this out and be able to determine what are some of the observations that you can make to determine if a chemical reaction has occurred. And then we're going to look at different reactions, and from the outcomes of those reactions, you're going to be given a couple unknown solutions, and you're going to have to try to determine what they are by how they react with some other chemicals. Okay? First of all, let's just go over a little background information. So a chemical property is indicating how a substance is going to react with something else. So it's properties that depend on how the material reacts with other materials. All right? And you're not guaranteed that what you're witnessing is a chemical reaction until you actually can prove that you have something different and something new. But there are observations that we can make. There's indications that a chemical reaction has occurred, and here are some of them. You might see a gas being given off. You might see a precipitate that is formed. That's a solid. You might see a color change. You might see a change in energy. Either heat is given off or heat is absorbed. Or you might even detect an odor. Okay? So those are just observations that we make that might help us determine if a chemical reaction has occurred and we now have something new substances different than what we had before. Remember, during a chemical reaction, bonds are broken, and those particles, atoms and molecules and whatever you have are going to rearrange themselves and form new compounds, new products, new substances, okay, that have different properties. Now, there are kind of two parts to this experiment today. The first part I'm actually going to hand to you, and the second part you are going to perform. Okay? So that's a little bit of our background information. We are looking at chemical properties today. Let's define a few terms just to remind ourselves some of the things that we've been talking about up till now. A solution, remember, is a uniform. You can be writing these in here. A uniform mixture. A uniform just means that it is the same throughout. Okay, we also use the word homogeneous. Precipitate would be a solid, and that is often formed, it might be formed from the mixing of two solutions, aqueous solutions. All right, let's go to AQ, aqueous solutions. A mixture, you have two or more combined substances. And we might be able to separate that mixture, okay, depending on the properties of the different substances that are being combined together. A physical property has to do with the nature of the substance, like shape, color, texture, also things like boiling point, melting point. Those are properties of a substance, and the property is not reacting to form something new. You still have the same substance that you started with after, that you end up with, that you started with. You're just looking at things that you can observe that give you a little bit of clue of maybe what substance you might have. Okay? Is it shiny? Is it malleable? Can you bend it? Things like that. A chemical property has to do with how does it react. How does it react with other things? Okay? When it is put in an acid, for example, what's going to happen? When it's exposed to the oxygen in the air, what's going to happen? Things like that. And then, of course, physical change is a change that does not alter the chemical makeup. Meaning, you might have a substance, you do something to it, but it's still the same substance. That's why, for example, if you take water and you boil it and it turns into water vapor, it's still water, it's still the same formula, it's still H2O, it's just in a different phase. That's just a physical change, okay? Or if you take a piece of paper and just rip it, it's still paper, different shape, different sizes, but it's still paper. A chemical change, though, is the chemical nature is altered. Right? You basically have a new formula. You have something totally different. That chemical change then, maybe when something burns, or something that goes through a reaction and you see bubbles. So all those different indicators we talked about before. When you see bubbles, maybe it's producing a gas that wasn't there before. Okay. An element, those are on the periodic table, and those are the building blocks of all matter. Meaning they all have one type of atom. An element, all the atoms of an element are same type of atom. Same, not type of atom really, but the same atom, same number of protons. Okay, an element is always, remember when we look at the atomic number, that atomic number is like its ID. The atomic number is telling you the number of protons. And every element has a unique number of protons. The number of neutrons can change, those are called isotopes, and the number of electrons can change, those are called ions. But for an element, a specific element, the number of protons can never change. A compound, two or more elements bonded. Okay? And then chemical formulas, it is a device that we use to describe what elements and how many of each atoms of each element are in that compound. Okay? So it is basically some nomenclature. Okay? I spelled that right there, nomenclature, to show what elements and how many of each are in the compound. Okay, so that's just a little review of some terms that we've been talking about up until this point. And number 11, we should be able to fill this in. In fact, we just talked about at the beginning here. Different evidence for chemical reactions. So we might see gas produced. You might see a precipitate. Okay, that definitely, if you didn't have a gas before and all of a sudden one is produced, something different is produced, and so you have obviously a chemical change. A precipitate is a solid that is formed that wasn't there normally. Right? You might smell a new odor. You might detect heat, and that might be your container in which the reaction is taking place. It might feel hot or cold. If it's hot, that means heat is being given off, and if it's cold, it means heat is being absorbed. Okay, and then you might detect a color change. Okay, or another one could be you might see, and this might go along with heat here. You might see light being emitted. Okay, if something's burning, or if there's luminescence. Okay, so those are some different changes, or so I should say some different evidence or indications that a chemical reaction has occurred. We're going to look at a number of chemical reactions today and talk a little bit about those, and you're gonna see some of these different indicators here. Okay. All right, let's go on and let's talk about the first part of our lab, our experiment today. Basically, what we're going to do is I'm going to first give you this information. You're not going to have to perform all of these reactions, and I'm going to give you some information about what happens when you combine these different solutions. All right, we've got a number of different solutions here, and we're going to look at what happens when we combine these different solutions. And I'm going to share that with you, and then you're going to use that evidence, and you're going to be given an unknown A, B, C, or D, and then you're going to have to devise and come up with a way to try to find out what that unknown is. It's going to be one of these 7, and you're going to have to try to figure out, well, what reaction should I perform to try to figure out which of these 7 solutions I have, okay? So I'm going to give you right now the outcomes of combining these different solutions. So basically what we're going to do is we're going to combine solution number 1, which is copper sulfate, with solution number 2, which is ammonium hydroxide. And I'm going to tell you what the reaction is going to be, what you're going to see. Not what the products are, but what evidence you're going to see. Are you going to see a color change, a precipitate, or whatever? Okay. Now, obviously, you'll notice some of these boxes are crossed out because we're not going to combine copper sulfate with itself. So that's gone. Okay. And also, you'll notice that we have solutions 1, 2, 3, 4, 5, 6, and 7 here. Okay. And then we list them down in this first column as well, so that we can make sure we're combining every possible arrangement. All right, so I don't need to repeat these. I'm actually going to cross out. What I'm saying is, when I do solution 1 and solution 2, and I record the results here, I don't need to do it the same thing in this box, solution 1 and solution 2. So I'm just going to actually cross out this whole bottom portion of our table, because I'd just be repeating myself. Okay, I'm just going to repeat it. So I just need to make sure that every solution is combined with every other solution, and I can do that just with the top portion of this chart. So I'm going to give it to you right now. I'm going to give you the results so that you know what would happen if I combine these different solutions. So if I was to combine ammonium hydroxide with, and the formula for that is NH4OH, there's your ammonium, there's a hydroxide, and copper sulfate is CuSO4. So if I was to combine those two, what you would witness, if you were to do that, would be a dark blue precipitate. So you can write in right here, dark blue precipitate, as well as the formulas for each of those as we begin to build this table. Okay? So what we're getting at here is, if I give you an unknown, I'd say you're unknown, I'm going to give you unknown A, let's say, and you don't know what it is. But when you test it with copper sulfate, you end up getting a dark blue precipitate. You might lead you to the conclusion that, oh, I think my unknown is ammonium hydroxide. So we're trying to match that up, okay? All right, acetic acid. When acetic acid and copper sulfate combine, you're going to see no reaction, or no evidence of a reaction, okay? The formula for acetic acid is CH3COOH, okay? Let's go with sodium hydroxide. Sodium hydroxide is NaOH with copper sulfate, and again you will see a blue precipitate. This one's a little bit lighter, a light blue precipitate. Okay. Here, sodium bicarbonate, the formula for that is NaHCO3. When that combines with copper sulfate, you again will see a light blue precipitate. Okay. Hydrochloric acid and copper sulfate is going to, this is HCl by the way, that's going to form a white precipitate. So you can be writing all these into your table right now. And number 7, the sodium carbonate. Sodium carbonate is Na2CO3, and that is going to give you also a light blue precipitate. Okay, so record those. Let's go to the next line here. When you take, so I've combined solution 1 with all of the other 6, 2 through 7. Now I'm going to take solution 2 and I'm going to combine it with all of the others. I already did solution 2 with solution 1. It's right up here. All right. So I'm going to do 2 with 3. So ammonium hydroxide, and you can see the formulas. I don't need to rewrite the formulas because you can see the formulas up here. Ammonium hydroxide and acetic acid. And that right there, you're not going to see any reaction there. Okay, I'll put none actually, okay, instead of crossing it out. Sodium hydroxide and ammonium hydroxide, again, you're not going to see any reaction there. And none here as well. HCl and ammonium hydroxide. Now, when we do this reaction, we actually are going to put what's called an acid-base indicator in there, and that's going to end up turning pink. Turn pink, and I'm going to put with indicator in it, with an indicator. And we haven't talked about acids and bases, but all you need to know is that it's going to turn pink if we add hydrochloric acid and ammonium hydroxide, and also have an indicator in there. Okay. Sodium carbonate and ammonium hydroxide, you are going to see no evidence of a reaction here. Okay. Let's go down to solution number 3 with 4, 5, 6, and 7. So 3 with 4 is going to be none. 3 with 5. 3 with 5, you're going to see bubbles. Oh, finally we get some bubbles here. Okay. And 3 with 6. 3 with 6 is going to be none. And 3 with 7. 3 with 7, you're going to see bubbles. All right. Moving on down, 4 with now 4 with 5, 6, and 7. So 4 with 5, there's not going to be any evidence here, none. 4 with 6, 4 with 6, again, when we put in an indicator, it's going to turn pink. With indicator, that's a separate chemical that's going to turn a certain color depending on whether it's acidic or basic. All right. And 4 with 7, 4 with 7, there's going to be no evidence here. Let's go 5, and 5 with 6 and 7. So 5 with 6, it's going to be pink. Then it's going to fade. It's going to be pink initially, and then it's going to kind of fade to being colorless. All right. And then here, there's none, no evidence there. Let's go hydrochloric acid and sodium carbonate. Hydrochloric acid and sodium carbonate, it's going to turn pink with an indicator. Okay. By the way, this one has an indicator up here as well with an indicator. All right. So we have all of this information right here, and all this information is now going to help us determine what our unknown is. All right. So we have all these different combinations, and we have these results. So if I was to give you unknown, say I'm going to give you an unknown solution, you would then have to look at this table, and the unknown solution is one of these 7. You would have to look at this table and say, okay, well, what combinations, what do I want to test it with to see if I can figure out what my unknown is? You see here that we had a lot of reactions up here with the copper sulfate. Blue precipitate, white precipitate, light blue. So you might want to first, just a suggestion, maybe test it with copper sulfate. If there's no reaction, you might determine that you have copper sulfate or you have acetic acid. So you might want to pick the one that has the most reactions. And then maybe kind of work your way down from there if you get no results. If you get no results, then you have to test something else and see if you get maybe bubbles. Maybe you test that next to see if you get bubbles. Maybe you've got acetic acid. Okay, test it with sodium bicarbonate. Or you might want to test it with hydrochloric acid and see if it turns pink. Then you might have one of these bases over here, ammonium hydroxide or sodium hydroxide or sodium bicarbonate. So you have to devise a way to test your unknown and figure out which of the 7 solutions you were given. Okay? Now, what I also want you to do is, I want you to answer these questions. So there are 8 questions right here, and these are going to kind of help you figure out how each of these chemicals react. So what you're going to do is, you can maybe screenshot this right here or copy down this. You should have it copied in your table, by the way. Copy down this information in your table, and now you should be able to answer these 8 questions right here. You're basically looking at what chemical properties of hydrochloric acid, what the chemical properties of hydrochloric acid are that it reacts with what. So look at your table. What does hydrochloric acid react with? Chemical properties of sodium hydroxide. What does it react with? Write that down. Chemical properties of sodium carbonate. Write that down. What does it react with? About ammonium hydroxide. What does it react with? Same with sodium bicarbonate, copper sulfate, and acetic acid. Write down each of these there. Notice there are 7 there. Write down what they react with so you get an idea. Okay? You can pause the video and do that right now. Number 8 says, suppose you mixed up the labels in solutions 2 and 3. Using the information from this lab, what tests could you use to identify each of the liquids? All right. So here, if you mixed up solutions 2 and 5, I don't know, 2 and 5, yeah, 2 and 5. If you mixed up 2 and 5, what could you do to test to identify each of these liquids? So let's look back at 2 and 5. Here's 2, ammonium hydroxide. Here's 5, sodium bicarbonate, right? If you mix those up, well, what do they react with here? Ammonium hydroxide and sodium bicarbonate. Maybe you could test it with acetic acid, because you'll notice ammonium hydroxide and acetic acid, there was no indication there. Okay? But with sodium bicarbonate, number 5, and acetic acid, here we go, sodium bicarbonate and acetic acid, you got bubbles. So you might want to react your solution, because you mixed up 2 and 5, it's saying. You want to correct that. You might want to have it react with acetic acid and see which one produces the bubbles. That's a possibility. Or I suppose you could react it with copper sulfate and see if you get a dark blue precipitate or just a light blue precipitate. That might be harder to figure out, but basically what you're doing is you're looking at the chemical properties and trying to figure out if you can determine and correct your mistake by having it react with something, so that you want to find a distinction between ammonium hydroxide and sodium bicarbonate. Maybe one of them reacts with something and the other one doesn't, as I said about acetic acid. Okay? So I'll let you write that down. Okay? Maybe react it with acetic acid. Okay? All right, so now we're going to test some unknowns. All right? Certainly, some of these unknowns are going to be harder to figure out than others, but we need to figure out a way to do that. Okay? So, if we are given unknown A, or unknown B, or unknown C, or unknown D, we need to figure out a way to do that. All right? So, if you are given unknown A here, let's say I give you unknown A, and I tell you we're going to first combine it with copper sulfate. So copper sulfate maybe is the first one to test, because remember, it has a lot of things that it reacted with. Let's look back up at our table. So copper sulfate produced a precipitate with a lot of different, actually 2 through 7, except for number 3. It reacted with everything except for number 3. So I'm going to first, with unknown A, I'm going to test it with copper sulfate. Okay? And for those of you that can't perform this experiment, I'm just going to tell you unknown A forms dark precipitate, dark blue precipitate with the copper sulfate. Okay? So, you might be able to conclude right away, I know what it is. But let's just test one more thing. You'll notice that also with hydrochloric acid had a lot of reactions as well, if you test it with hydrochloric acid. So I'm going to take the same unknown A and test it with hydrochloric acid, and the results are with HCl turned pink when an indicator was present. So from that information, if it forms a dark blue precipitate with copper sulfate and it turned pink when combined with HCl, you should be able to conclude what unknown A is. So right here, I look at this, dark blue precipitate when combined with copper sulfate and turned pink, and I notice that that also happened. I'm leaning toward ammonium hydroxide, so let's see what happens here. Ammonium hydroxide with HCl, yep, turned pink. So I have concluded that I probably have ammonium hydroxide as my unknown A. All right, see how that works? So unknown A is, I'm going to put it down here, ammonium hydroxide. All right. So I'm going to give you, for those of you that can't perform this experiment, I'm going to tell you some of the results when we take unknown B and react it with something, unknown C and react with some things, unknown D, and then you're going to have to tell me what you think. Look at the table and you tell me what these different unknowns are to the best of your ability. Okay? All right, unknown B. Let me do this actually. I'm going to pause the video and I'm going to write in the reactions and then I'll show it to you, and then you can look at your table and try to determine what the B, C, and D unknowns are. So I have filled in how these different unknowns react, and let me go through them, and then it's your job to conclude by looking at the table I gave you before, conclude what the unknown is. So unknown B, when you combine it with copper sulfate, it will produce a light blue precipitate. Okay, so that narrows it down, but now I'm going to also test it with HCl. With HCl, it went pink and then it faded. Now that might help you right there, and you might be able to make your conclusion, but let's test it one more time with something else just to be sure. We tested with acetic acid and we got bubbles. So light blue precipitate, pink then fades, and bubbles. You need to determine now what is unknown B from that information. Let's look at unknown C. Unknown C, again, I tested with copper sulfate. I got a light blue precipitate. Now, it might not be as wise of me to test it with copper sulfate because there were a lot of reactions that gave me a blue precipitate. You know, there were three. One was dark, maybe two were lighter, but still, maybe I want to use some other reaction to try to eliminate more of my first reaction. But in any case, I did a light blue precipitate was formed with copper sulfate. So that narrows it down a little bit. Then I did HCl and it was pink. It turned pink. And then I'm going to do one more just to narrow it down because I'm not quite sure between a couple. So I did acetic acid and I had no reaction, no evidence. So now from that information, you have to tell me what unknown C is. Unknown D, I tested with copper sulfate again, nothing happened. Now right there alone, you might be determining what it is, but let's just double check. So I think I know what it is, but let's test it with sodium bicarbonate. I saw bubbles, and I'm going to confirm one more time. I'm going to test it with just sodium carbonate, and I got bubbles again, and you should be able to tell me what unknown D is. Okay? So make sure you have the entire table filled in. Make sure you have these evidences for unknown A, B, C, and D filled in, and then you should be able to tell me what these different unknowns are. Give me the names of each of these right here from what I've shared with you. Okay? So this whole experiment was all about chemical properties. And by the way, these chemical properties don't change. A compound has the same chemical properties all the time, and it reacts with different substances, different solutions, exactly the same every single time. That's why we're able to fill in the table and then from the unknowns be able to conclude what we have. This doesn't change. Okay, a compound is not going to react one way with HCl and then tomorrow it's going to react a different way with HCl. It is always the same, very predictable, not random, very consistent. Okay, so that's the cool thing about this is we know exactly what's going to result, and we can make predictions and plan accordingly. We can do that experiment over and over and over again. Okay. All right, so I hope this was helpful. Make sure that when you're done filling everything in, you take a picture and upload it to our Google Classroom for this particular lab assignment. All right, great job. Let me know if you have any questions.